Hello everyone, good afternoon, dear authors and invited guests. I welcome you all to the technical session 5G. Myself Siddesh Mogal and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025 Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 9, 16 and 17 December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter would be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. So just before we start the session, I would like to introduce all to the chair of this session, Dr. Kalyan Devappa Bhamane. Dr. Kalyan Devappa Bhamane is a associate professor at D.Y. Patil College of Engineering, Pune, India, with 19 years of teaching experience and a PhD in computer science and engineering. His area of specialization include computer network, cybersecurity, distributed system, and software engineering. Sir, do you have any opening remarks to the participants? Moving towards our presentations, our first presentation is presented by Dudekula Brahman. He is presenting a data-driven dashboard for workforce analytics and decision support. Sir, are you there?
Yes, sir.
So you can start your presentation.
Yeah, okay, sir. Good afternoon to everyone. I would like to introduce myself to you. My name is Dudekla Brahmam. I'm currently pursuing my BTech final year in Kalasalingam Academy of Research and Education. Today, in this conference, now I'm going to explain you about my project, a data-driven dashboard for workforce analytics. So let me share you my screen. Okay. Let me tell you a brief about our project. In today's competitive business environment, human resources plays a pivot role in driving organizational success. So, deriving some actionable insights for HR data remains a challenge for many organizations. So, for that, our project focusing on developing a complete data analytic solution for HR data using Python, SQL, Excel, and Power BI, Power BI or Tableau, both any one of the tool for visualization. The main objective of our project is to transform the raw employee records into a real-time interactive dashboard that aids HR manager in making informed decisions. So here the main objectives are provide a comprehensive workforce insights, which means we can deliver a interactive dashboard for HR managers to monitor, analyze and understand the workforce trends at a glance. So another thing that workforce monitoring, tracking and visualizing key HR metrics such as hiring trends, active versus terminated employees, and departmental distributions that and all. So in addition to that, income and pay equity insights also can be done by this. And our project is going to satisfy three SDG goals. That another first one, SDG 5, gender equality, and another thing SDG 8, decent work and economic growth, and another thing SDG 10, reduced inequalities. Here some of the tools we have used to attain this solution. Python programming language and Power BI, VS Code and Colab notebook for running or executing the codes. Uh, Here are some of our research literature surveys that and all you can see. Comparison between the existing and proposed solutions. Many studies rely on heavily on the descriptive statistics and basic statistical test, often lacking predictive modeling capabilities for future trends. So, in our proposed system, we are trying to include the machine learning. So, for the attrition predictions, that and all. Uh, Let me share you another thing. My project. Sir, is it visible to you, sir? The dashboard?
Yeah, yeah.
Okay. Yeah, I think is it clearly visible to everyone? So here is the final dashboard which we have created by using data set. So in this you will be having three three containers. One is overview, another thing is demographics, another thing income. In overview, the HR is gonna get to know about the active employees, how many active employees are there, and how many hired, and how many of them are terminated. In addition to that, by the departmental wise, he can also evaluate them. So the total number of employees hired, you can see in the numbers and the percentage, and that also total by job titles also he can see. Another thing, here the total number of terminated employees also he can see by the departmental wise. And here we are having two locations. One is headquarters. Another thing is different cities. So branches like that. So here he can see in the New York the status of employees is gonna be New York City. 2,900 members are there, and Buffalo 1,500 members are there. So like that he can also get to know how many members are there. So here total number of employees in headquarters he can also get to know from this, and from the branches how much percentage of the employees are there. He can also get that from the overview. When it comes to demographics, here he can analyze the data based on this gender, female employees how many are there, and the percentage of that. Here we can go for the male height and that and all. So here education, the bachelor, total number of the, here we are having four categories. One is high school, bachelor's, masters, and PhD. So according to that, the age in the bachelor's, the total number of employees are 15,000. So in that, less than 25 age are 408 members, and between the age group of 25 to 34, 1,300 members are there. So around 35 to 44 age, 1,500 members are there. So likewise, he can get to know that how many of there in our company, and how many employees are there between this age and between this education, that and all the HR is gonna know. And here the education and the performance, here the HR can come to know that in high school total number of employees are 234, and that means their performance is high. Here most of the in PhD total number 288 members are working good, that means excellent. So when it comes to good, that and all, he can also get to know about that what excellent, good, satisfactory, need improvement in the employees. Here when it comes to high school, most of the peoples are need to improvement, need their improvement in their performance. So that thing he can come to know, so that he can just get to know about how they are working and all those. When it comes to here, based on the gender and income, the salary how much they are providing to the high school education, the based on their educational qualification. So for male, it is average salary of 63K in to those who educational qualification is a high school, and for the female it is 61K. So same like bachelor's 66K female. If the females are, if the male sorry, females are doing masters, then they are getting a huge amount than the males. Like that also they can come to know. And here you will be having filters option where you can show and hide all your filters. And based on this, you can come to evaluate if you want generate insights only for the mail. You can just keep mails as it is. So you'll find only the dashboard will show you only the data related to the mails. And if you want only the data related to females, means you'll come to know about all the data about the females only. So another thing that here we can come to status, whether you want data related to hide or terminated, that also he can get to know it at a glance. So this we are getting trying to know about all the females and males who are getting terminated, that and all, and their performance, their average salary, income, everything you can get to know from adjusting these filters. Another thing here based on
Sir,
the branches.
sorry to interrupt, but your 9 minutes are over, so kindly wrap.
Yeah, okay, thank you. And this is the thing you the HR can come to know. And here you will be having details of that data set, that and all we have used. Thank you, sir.
Lan, sir, are you in a meeting?
Yeah, okay, sir. Completed.
Okay, okay, sir. No,
The main thing is that the dashboard only, which we
okay,
have created. Yeah.
okay, sir. No, I'm actually asking about session share. I think he has some technical issue. He has not rejoined it. Okay, we'll move further.
Yeah, okay, sir. Proceed.
Yeah. Next, we have E. Bikram. He's presenting a multimodal approach for crop health optimizing using adaptive deep learning.
So, hello, sir.
Yes, sir. You are audible.
So, this is Vikram. I'm from Andhra College of Technology, currently pursuing my bachelor's degree in information technology. So, let me share my screen. Is it okay, sir?
Yeah, it's visible.
Yes. So, my project is about a multiple approach for crop health optimization using adaptive deep learning. So, it's use of AI and ML processing. So, it's just abstract is about. So, it's just recommend the suitable crops for the suitable area of fields, crop fields. So, using the ML processing. So, it's a how the model implementation we use the linear regression and the MLP process to handle the prediction and suggestion things, and also handle the complex data sets. So seasonal segmentation. So our project mainly focused on the segmenting the seasonal forecast by what we need by year. It's not comparing the overall compensation. For example, if we start from 2016 to 20, so it's the old thing existing system. Compare the overall percentage. So, but our proposed system separately segmented. So by year by year. So it's the main advantage of our system, and it's evaluate the performance of the suggestion and practical application. We can implement it in the other web services for the usage. So yes, the introduction is about to it's just filter the crops suitable to the area field, and just suggesting the best crop suitable to the field by using the input data. So this is the thing. It's mainly focused on the precision agriculture by the crop productivity and the crop health optimization. Then these are the research objectives of our project. So first of all, it go with the data collection about the historical data, and the area should be the plant should be grown, and what are the needed things, which type of crop we going to, some type of data should be inputted with the past data. And the data should be and the seasonal data should be derived and segmented. So using your ML and machine learning process. So LP and linear regression and MLP process, and then the model should be trained and evolve the previous data and suggest for the new things. So the what are the existing systems? The existing system have a IDBN architecture, though improved bit interest. So why we are from this, the IDBN is a complex process, heavyweight structure. So we improved the MLP and LR from the IDBN. So it's need also large data sets, and it's a complex process too. So and it's need a takes high processing time of the existing systems. So these are the limitations. What I said, the process time is high and need a large data sets, and weather unpredictability. That means less accuracy in the prediction of data. So because of the overall comparison of the data set, past seasonal data sets. That's it. And then what our proposed systems are going to be. So our proposed systems have a only have need to input data location, because we already model trained the location wise soil crop details from the internet, and then it's save the soil characteristics, and need to give the seasonal data. So we'll give the data set, it automatically separated by using the LR models and the MLP models. So LR any relations will create the relations between, and MLP captures the complex linear pattern of the seasonal data. So it's helps for the accurate prediction of the seasonal upcoming future product, and that's helpful for the crop recommendations. So the prediction generation, the suitable crop should be predicted for this field as per the future seasonal things, and then it will be continuous learning process. So because of the recent updates, because existing system does not have the continuous operations, our systems we include continuous learning operations, so it would be uh, having the immediate changes of the climate changes, so it's handled the that sudden changes of the environmental factors should be handled by our systems. So these are the system advantages. So it's by using this LR and ML, the increase in the accuracy of the crop recommendations, and also by this accurate accuracy, the fertilizer optimization also happen. And then it's a hybrid approach, as I said. The linear regression is predictor for the crop recommendation, and MLP capturing the complex patterns of the seasonal data and other past data for forecasting. And this supports this data-driven decisions and adaptive systems. It also this results in the enhanced productivity of the crop. That's also maintenance of the crop health. So these are the basic system requirements of our projects. They're using some of the latest processors, and it's RAM and ROM. Then operating system with 10, and a front with a Python streamline, and a coding language with Python. That's it, done with the creating of the project. That's it, sir. Anything questions, sir?
Up next, we have Barnabas Finiti. He is presenting a multivariate ordinal logic analysis of mental health status among Indian university students. Sir, are you there?
Yes, sir. Can you hear me?
Yeah, sir. You can share your screen.
Yes, sir. Yes. Yeah, sorry. Uh, so this was done to understand the mental health status among Indian students. So the motivation and the background behind this is actually uh, we know that mental health actually influences academic performance and well-being, but again, this is not proven. And as we also know that mental health is kind of seen like a stigma in India. It still is a stigma in India, and so people are very sensitive about this. But again, understanding and getting a better idea about the mental health can actually help influence and enhance the way students are, and also to have a better mental health status around the nation. So what I did was, so this was the abstract. So what we found from the entire study was this, that uh, the mental health positively affected the university students. And when we see about it, we see that the physical health of the students actually uh, the physical health of the students contributed very much to the mental health of students, because if if there is better physical health, then the mental health is also good. And again, the stress factor came in uh, uh, as the negative approach, where the more the stress is, the less the mental health status is of the student. So the research gap was, a lot of studies aren't done in India, especially as I told before, because of the stigma of the topic of mental health. So again, there was very limited evidence of how mental health affects students, especially in India. So what we did was our study was to do a mental health study with an ordinal outcome, that is they had five options saying my mental health is very poor to up to fifth point, which was my mental health is excellent. Again, this was a self-rated mental health study, so they rated their own mental health status from 1 to 5, and again it's relative, but the questionnaire, the entire questionnaire was divided into two sections. One was the internal resources and the other one was the external stresses and behaviors. So, and also made sure that I would able to get the predictive probabilities to actually check that this study is actually true, and again comparing it with other studies. So the data was 122, the sample size was 122, and again the outcome variable was self-rated mental health from very poor to excellent, and the structure was such that it was divided into two sections. So one was the internal factors like self-perception and cognitive and emotional control, and again relationships and healthy coping mechanisms, and the external stresses were again screen time and academic and financial stress, sleep and time management, peer pressure and stuff like that. And what we did with this was, since this was an ordinal outcome, we took the ordinal logistic regression where the outcome was ranked from 1 to 5. And again, what we did with that was we divided the entire model into three. So the one was the internal factors, and the second one was the external stresses. And again, a combined model was done so that I'd be able to get the factors which was affecting the mental health the most. So again, the interpretation was the odds ratio, which is the measurement of the ordinal logistic regression model. Uh, so again, I went to the diagnostics and validation to make sure that this study is proper. So again, there was no multi-collinearity, and again, the models were checked by the AIC values, and again, the reliability came around 0.70, which just shows that the questionnaire was consistent, internally consistent the whole way. And these were the results that I got from the final model. So physical health actually uh, shows a double odds of higher mental health. That is, if a person is physically healthy, if he has a healthy lifestyle, his mental health also would be healthy. At least it's doubled in this study. And again, the academic and financial stress has actually halved the odds of better mental health, which again shows that this is not really a good thing. Uh, and again, other non-significant uh, factors were the knowledge about mental, that is proper awareness about mental health, because again mental health has to be defined in a way that it's not just the state of being good mentally, but again it's divided into a lot of domains. So again, the awareness of mental health should be known, and again coping strategies and sleeping and screen time also came close. And I made sure I would do the predicted probability so that I would make sure that these were actually right. And again, it showed higher physical health and lower stress actually showed 80% probability of excellent mental health, which actually proves that uh, higher physical health means the better mental health again. And again, discussions is uh, as it was in a university setup, again promoting physical health and reducing academic and financial stress would again help improve the mental health of the students. And again, uh, it is mental health is multidimensional, it's not just defined in one particular way. And the conclusion would be uh, this ordinal regression model did prove out to be useful, because I did check with other mental health, similar mental health studies, which again prove the same. But again, the limitation was this is a cross-sectional design, and the sample size was very low. And again, it is self-reported, and I am not from a psychological background, so again, that should also play a role in it. And this does have a lot of limitations, but again, this is at least a start where we can actually try to do this more in students, at least in India. And again, future works should be done with a professional and expert in that field so that it is more precise and accurate. That is it, sir.
Thank you, sir. Moving further, next we have Ruta Mulajkar. She is presenting development of road anomaly detection system. Ma'am, are you there? Ruta?
Yes, am I audible?
Yeah, ma'am, you are audible.
Yes. And my screen is also visible? I hope so.
No, ma'am, I'm not able.
Screen is not visible.
When your
Okay,
screen is visible, just put it in a presentation mode.
yeah, I will do that. Now, is it okay? Is it
Yeah,
visible?
ma'am.
Yes.
Yeah. Okay. So my topic is development of road anomaly detection system. Let's see the introduction first. What are the challenges in the road condition nowadays? If you observe, or from the last so many years, we are observing that roads conditions we found very much deteriorating conditions, right? Which may cause the safety hazard and traffic disruption, especially during the adverse weather. Like if you observe in the rainy season, we'll get many potholes or or even open manholes. There are so many, debris on the road. So, what are the limitations of manual inspection? Manual road inspections are slow and it is definitely tedious as well, which is time consuming and may fail, may cause with the errors as well. So, there is a solution, automated detection system, which we have implemented with the help of YOLO V8 algorithm, which is you only look once. So, what are the benefits of automation? Automation definitely reduces the accident and improves the maintenance, enhance overall road safety as well. This is the one of the survey report released by Center for Transport Research and Injury Prevention, IIT Delhi. If you observe in this diagram as well, the pedestrian or the two-wheeler drivers are more impacted with the help of means for accidents, and if you observe the occupants which are having the four-wheeler are less impacted. So, significant public health issues in India are due to accidents on the road, especially among the people between the age 15 to 49. So, this observation, this is the death rate per 1 lakh people of the pedestrian, motorcyclist, and the four-wheeler occupants in 2021. Let's talk about the problem statement and objective for the project. The proposed system is to assess the road condition, detect the road anomalies. Here we have included potholes, waterlogged potholes, debris, cracks, and open manhole. Total 5 anomalies we have included in the research using state-of-the-art deep learning algorithm, that is YOLO V8. What are the objectives? Definitely to create and assess a deep learning based system that can precisely identify and locate the road anomalies in real time from pictures, or you can say the video data. Next is examine and evaluate the current road anomaly detection technique. Create a label data set of photos, or you can say images and videos. Evaluate the various deep learning architecture performance. And finally, identify the anomaly from the vehicle or mobile. So there are different techniques which are available for the road anomaly detection. Let's go one by one. First is the vision based technique. So here, if we observe, the data acquisition is done with the help of camera or the smartphone sensors. Then it is pre-processed, that is under the pre-processing we can say there is image enhancement, augmentation, data cleaning, then the feature extraction. you can subtract the background, especially in the feature extraction, and extract the features. Further, it applies to the YOLO network or the convolutional neural network. Finally, evaluation is done with the help of precision recall F1 score and MAP, that is mean average precision, and it will show that anomaly is detected. So main thing over here is we can say the data acquisition is with the help of cameras and sensors. Next, we'll move to the vibration-based techniques. So data is collected or the images or videos are collected with the help of sensors such as accelerometer or the gyroscope, which are built-in things in the vehicle, we can say, to detect the irregularities. And the further process is definitely pre-processing, then the classification and evaluation. Finally, we'll get the output. Next comes detection. The 3D model of road surface like stereo vision or the lidar scanning is used. Okay, light detection and ranging, that scanning will be done, then structure from the motion. So again, after getting the data with the help of sensors, we need to pre-process like noise filtration we need to do, then the downsampling, then finally you need to classify the particular anomaly, which type of anomaly is detected, and evaluation of anomaly will be done. So in our case, we are going to use the deep learning technique. Out of these four techniques, under the deep learning, data acquisition is again with the help of cameras or videos, we can say drone, and then uh, pre-processing. Under pre-processing, image normalization. Whenever you are going to feed the data to a particular algorithm, then you need to resize that image, and then the further processing will happen. Then aggregation and enhancement in the feature extraction. Uh, Train a model, so you need to split the data accordingly. Like here we have splitted the data as 70, 20 and 10%. 70% is the training, 20% is the validation, and 10% is testing. So different algorithms, and we can say the architectures are available. CNN architectures, ResNet, CSPNet. YOLO V8 uses the CSP backbone as an architecture. Let's talk about the YOLO V8 model overview. The advantage of YOLO V8, that is the version 8, over the rest all versions, is that it is an anchor-free object detector, which gives the high accuracy, definitely. And it is a single shot detector. What it means single shot? That it detects a particular object in an image and classify at the same time. That's why it is known as single shot detector. As I mentioned earlier, the backbone is used as a CSP darknet for the feature extraction. NEC will do the feature aggregation, or the feature enhancement will be done with the help of NEC. So there can be different NEC we can use here, like mentioned is PAN aggregation network. So this is again aggregation network, and head generates the bounding boxes and the class labels further. So now let's talk about the diverse image collection, like data set. We'll talk about the data set over here. What all things are mentioned or done under the data set. So there are total 5 classes or the 5 anomalies we are going to detect in this process. Data is collected either from the net, or the images are collected with the help of camera. Then annotation process is done. Annotation means we need to specify where that anomaly actually present in the image with the help of bounding boxes. So for that we have used the RoboFlow with the manual verification of the bounding boxes, and class labels for the precision. Under the augmentation, it is kind of image transformations, different transformations such as flipping for the image, rotation of an image, brightness adjustment, blurring. So many techniques are available for the augmentation. So collected images are 5K plus, and the augmented images are near about 13,000 plus we have done. Further, as I mentioned, the splitting and standardization for the image is required for the algorithm processing. This is our model or the sequence diagram. The explanation over here is user is going to feed the data to the system. It will pass through the YOLO V8 engine. So YOLO V8 contains the backbone, which is a pre-trained convolutional neural network. Okay, CSP we have used here. Then neck, and then the head, and finally training loop, right? So this explains overall sequence of our research. Let's talk about the result. So if you observe in this image, see the pH indicates the pothole is detected with the score, okay, confidence score we can say. So how much confident we'll get here? Like 80%. So WLPH stands for the waterlogged pothole. DB stands for the debris. Okay, over here. Then the cracks are there, which are indicated by CR. This is the experiment result demonstration, which gives the high precision anomaly detection, real-time system architecture, low latency for the motion JPEG pipeline. So definitely, if you feed the video as an input for the system, it will process with the low latency. Then the practical application, which will help the authorities.
Ma'am, sorry to
Yes.
interrupt, but your 9
Yes.
minutes are over.
Oh,
Kindly
okay,
wrap.
just I will move to the conclusion. Yes.
Yeah.
Yeah, just these are the result as I mentioned already. Let's talk about the conclusion. The study has successfully demonstrated the design and development balanced data set we have created here. Larger models perform the significantly better on the complex data set. And as I mentioned about the latency as well, for the videos, it will give the low latency. Then let's talk about the impact, which improves the road safety, suitable for the large scale urban rural deployment over here. These are few references. Thank you. Thank you so much. Yeah, I will stop sharing. Any, um, shall I stop? Yes,
Yeah,
I
ma'am. Yeah.
already, yeah,
Thank you.
fine. Yeah, thank you.
Moving further, next we have Yasir Hamid. He is presenting integrity violations and emotions monitoring system for online interviews using intelligent facial and behavioral analysis.
Yeah, hello, am I audible?
Yeah, you're audible, sir. You can continue your presentation.
Okay, I just present my screen now.
Yeah.
One sec.
So there is a background noise from your side. Can
One sec. I will. The screen is visible, sir.
Yes, sir. You can proceed.
Okay. First of all, good afternoon, everyone. Myself, Yasir Hamid. I'm a final IT student at the Undergrad of Technology. Today, I'm going to present my conference paper on integrative violations and the emotion mind system for online interface using intelligent facial and behavior analysis. Okay. First of all, our problem statement our problem statement based on the sorry, the rapid adoption of online interviews. It has some challenges to maintain the interview integrity. So, from the tradition manual, was it this insufficient? We have implement the AI solutions. So, what are the key issues on online systems? First one is an identity fraud, and another one is an off-camera behavior and external help from other persons. And third one is an notes. They used external notes to violate the interview, and also environment inconsistencies too. So, what are the limitations in the current system to identify this problem? First one is the unimodel system inaccuracy. There are the model used in the current situation, the CNN models. This has a lower accuracy to predict false or negative emotions. And also the environment sensitivity. The very light conditions, it has a background noise, so it has some less accuracy to predict users users trustability. And also gas estimation. The gas estimation means the eyeball detection, which helps to analyze the eye movement of the interviewer, and also human bias and inconsistency. It evaluates the human errors in the interview. Then our proposed systems, overview here. First was the face emotion direction. It has the combination algorithm we used here, and also gaze and head pose direction, which will help to predict the eye movement and head tracking, and also voice emotion honest, which will help to avoid the external fraud in the interview process, and also multimodal future engine, which helps to combine the multiple algorithms like ULDP and CNN algorithms, and also integrated score output, which will help to analyze the interviewer the candidate's score based on the interview performance. And here, what is the decoding operations we do? First one is a deface algorithm, which will help to predict the high level accuracy in the video processor. And ULDP is a traditional algorithm which will help to the micro level pattern analysis. What we implement is a hybrid fusion formula, which will help to predict the um, accuracy with the help of the combination of deface algorithm and ULDP, and it will help to analyze the union's emotions based on seven major emotions: anger, disgust, fear, happiness, and sadness or surprise also. Then, okay. Gas and rate post direction, how it will be distract the interview scenario. First, the CNN based algorithm which help to predict the iris movement, iris detection, which will help to find the iris on the face on the during the interview process. And gas vector formula will help to predict the eye movement in the sorry eye movement on the during the interview process. And the third one is PNP algorithm, which is the perspective endpoint algorithm, which will help to find a head post based on by the X and Y matrices. Then, how we implement the voice emotion system analysis? We implement the MFCC extraction, which will help to analyze the short-term power spectrum sound, which will be the vocal vocal sound, which will be recorded in the starting, and it will be frequently comparing will help to analyze the emotional state of the candidate. It will help to find the candidate between the stress or discomfort, and also decision capability, which will help to the monotone speech, which will if the tone is in the same pitch, it will be easily find it is as an A generated voice. Then how we implement our multimodal fusion model. First one, we implement the four major operations. First one is the gaze score. Gaze score is based on our eye movement and head pose analysis, and also face emotion score. Face emotion score is which is based on the seven major emotions which I already told, and also voice emotion score which is predicted by the MSCC and emotion patterns, and also weight fusion which will integrate these three major scores and provide the optimist weights to produce the integrity matrices. Then, what are the accuracy scores we got? First one is in a hybrid model. We got this 89.4% accuracy in a face model, and also gaze tracking. We got an 80 to 92% accuracy by our algorithm. And voice emotion also it will come up to 75 to 86% accuracy. So overall, our accuracy will be across 80, 90, above 90 percentages. If we compare it to the previous algorithm, CNN has about 70% of accuracy, and DFS alone DFS it will give it as 80 to 85% of accuracy. But our hybrid solution which will help to produce a 90 above 90% of accuracy, and also the system latency will be also very less. It will be around 85 milliseconds. based on our testing. Okay. In the conclusion and future work, I will need to explain about the um, our conclusion and what are the improvement we need to do in future. First, our conclusion: this real-time multimodal system will help to integrity in the during the online interviews, and also achieving high accuracy on the human emotions, and also reduce the human bias and enhances the fairness in the evaluation process on the for the which will help for the HR. And for the future direction, in investigative cultural adoption, emotion integration may be more maybe improve um, maybe improve by enhanced data sets, and also integrate a full body gesture tracking by improve the pattern enhancement algorithm, and also explore the cloud-based deployment, which will help to access in the scalable for every every company and every users and the IT sectors. Yeah, that's all about my presentation. Is there any queries?
Up next, we have JS Madhuvanti. She is presenting Neurosign, a real-time CNN and OpenCV-based platform for gesture to language translation and interactive sign language. Ma'am, are you there?
Yes, sir.
Okay, ma'am, you can start your presentation.
Okay, sir. This is Madhuvanti from Nanda College of Technology. I am currently pursuing my final year BTech IT. So let me share my screen. Okay. My topic
It's
is
visible.
Sorry, sir.
No, your screen is visible. You can proceed. Sorry to interrupt.
Okay, sir. Okay, sir. So my topic is Neurosign, real-time CNN, an OpenCV-based platform for gesture-to-language translation and interactive sign learning. So it is a camera-based system for translating the American Sign Language into both text and speech with the help of computer vision and deep learning. Okay, for the hearing and the speech impaired individuals, the communication will be a huge problem, and for them, they are using the sign language as their vital communication tool. There is already an existing system for helping them to uh, recognize their sign language. That is a glove-based system, and the glove is based consists of so many expensive sensors, and it is very costly, and it is very heavy to wear. So these are all the struggles in the existing system. So this, as I said, this is the problem. The solution we gave is a camera-based system, which is very affordable and which eliminates the hardware usages. And with only help of webcam, we can detect the sign language, and we can convert it into the text and speech. So this is the solution we gave, and our aim is to build a bridge that helps to translate the American Sign Language into both text and speech. So addressing the research gap, as I said, there are some limitations in the existing system. The major disadvantages is the high accuracy can only achieved with the help of expensive sensors and hardwares. And when the lighting conditions and environmental conditions varies, the performance degradation will be there. And if the processing speed is low, it will affect the real-time interaction for the signers. Then that there is only limited vocabulary for the that's covering only the basic signs, and there will be lack of robustness in the real world interactions. The neuroscience system we gave solved all these problems. With the help of CNN models, we trained with 5,000 plus American Sign Languages that is inserted in the model. And for after that, in the webcam, if you do the sign in front of the camera, it will detect and with the help of OpenCV and MediaPipe, the detected hand sign according to the words and letters will be showed on the display. and also the speech output will be there. So why I chose the American Sign Language is there is available 5,000 plus signs, and it is the English is the common language we are using all over the world. But the existing system only made for the Polish language that has only 32 letters, so they only speak to the Poles. So if they want to communicate with other than the Poles, they can't. So for that, we gave the solution. It is purely vision-based system. So we don't need any other wearable sensors or equipments. Then the performance will be high, which is 95% accuracy with 0.8 seconds latency. Then the environmental robustness is high. Why? Because the stable performance across different lighting conditions we can achieve with the help of OpenCV and MediaPi. Then these are all the research objectives, which is non-wearable system design. So as per the existing system, we have to wear a gloves and it is not portable to everywhere. So for that, we gave this solution. Here, we need only the camera that can recognize the American Sign Language, and it doesn't need any sensors. Then the second one is real-time detection pipeline. With the help of OpenCV, it will detect the hand and it can pre-process the live video streams. Then the CNN classification model we used to train the model, it will classify the hand gestures that is representing the ASL letters. Then the multimodal output, the sign will be converted into both text and speech, as I said earlier. Then the performance validation will be very high accuracy and precision, and it has a robustness across real world testing conditions. Then the literature review. So we have already some prior approaches for these challenges. There can be spatial attention networks for feature localization, then the LSTM based models for sequential translation, and also the transformer architectures for sign recognition. Then the hybrid CNN HMM systems, which combine the both deep learning and statistical learning. And but there are some challenges in those approaches that are the complex hardware dependencies and only the limiting deployment. Then the high computational and financial cost is there, and it's difficult to handle when the dynamic and the contiguous gesture is there. Then it is only helpful for the limited real world applicability. So for that, we gave the solution which combined both OpenCV and CNN, which classifies and identifies the hand gesture pattern, and it will convert it into the text and speech. So this is the system architecture overview. First one is the gesture acquisition, which means the webcam will capture the live hand gestures. Then we will pre-process it. With the help of OpenCV, it will extract the pattern of the hand gesture and it will normalize the hand regions. Then the feature extraction, which means the hand landmarks and geometric features will be identified. Then the classification, which is deep learning model recognizes the ASL letters and the output generation will be like text and speech. Then the methodology we used here is the data acquisition and pre-processing. The data acquisition means, as I said, the video streams will be captured through the webcams and we doesn't need any specialized equipments for it. And the system was tested with the 10 users with multiple indoor environments that will ensure the generalizability. Then the pre-processing pipeline will be the background removal that helps to isolate the hand region from the surrounding environment. And then the hand segmentation will be there that will precise the boundary detection and extraction. Then there will be noise reduction that filters the artifacts and improve the signal quality. Then the normalization, which helps to scaling and standardization. Then the landmark extraction, which helps to identify the key hand geometric features. So this is the CNN architecture. So the input given will be the 128 into 128 pixel hand frame, and there are different layers, architectural layers. The first one will be the multiple convolutional layers for feature extraction. Then next will be the max pooling that helps for the spatial dimensionality reduction. Then there will be a layer called RELU activation functions that is helpful for the non-linearity. And then the fully connected layer is there that will helpful for the high level reasoning. Then the softmax output for the 26 ASL letters will be there. Then the model was trained with 5,000 labeled frames that completely represent the ASL alphabets. And the performance matrices will be the accuracy, which is the overall classification accuracy across all the OSL letters will be 95%. Then the precision, the race, which means the ratio of correct positive predictions will be 0.93%. Then the recall, which means the ability to identify all the relevant instances will be 0.91%. Then the score, which means the harmony mean of precision and recall will be 0.92%. Then the result and impact. So in the indoor lighting, the accuracy under the natural lighting conditions will be 95%. Then with the help of artificial lights, the performance with the indoor lighting will be deferred to 93%. And when it comes to cluttered background, the robustness in complex environments will be reduced to 91%. Then the key contributions are we want only webcam for this process, and the gesture will be translated into speech with less than 1 second latency. And then it ensures the high accuracy and environmental robustness. And here we are using the CNN and OpenCV, which helps for hybrid pipelining. Then it is very cost effective and user friendly design. So the conclusion and future scope. When we comes to the conclusion, here we helps to reduce the communication gap between the signers and non-signers. Non-signers means the one who doesn't use the non-sign language. So it helps to interact the signers with the non-signers effectively. Then it is a very affordable and accessible platform for the ASL translation, and it helpful for the hearing and speech impaired individuals in different fields like education, medical, and social like that. And the future enhancements can be expand to 3D gesture recognition and dynamic ASL words in the future. And we can also develop a multilingual sign language support for the system. And we can also create a mobile app or a AR, VR, which is augmented reality or virtual reality applications in the future. Then we can implement cloud-based translation services. Then also we can improve the background adaptation algorithms. That's all, sir.
Thank you, Madhun. So we
Thank
have
you,
our
sir.
session chair with us. Sir, do you have any questions?
So
Kalyan, sir?
no,
Yes,
sir.
yes. Am I audible? Am I audible?
Yes,
Yes,
sir,
sir.
you are audible.
Yes,
Sure.
sir.
Actually, can you show me the result wala PPT, please?
Yes, sir.
Yeah. You have mentioned here that key indoor daylight 95%, AI artificial is 93, and cluttered is 91%, right?
Yes, sir.
So what is the exactly outcome of all this out of it? What is your gain? How much
So,
percentage? Somebody has already done this task. So once you have done it, that comparison, how much you gained it,
so already it was 92%.
right?
When it is when they are using the indoor lights and artificial lights,
Hmm?
but we achieved it as 95%, sir.
So your gain is of 3%, right?
Yes, sir.
Because already 92% was there.
Yes, sir.
And that time, what was the algorithm they had gone for?
So they used, sir, I couldn't recollect it now, sir.
No, no, no problem, no problem. You just let me know about that key. Why you have chosen this CNN and OpenCV combination?
So because in the Python, it will be very effective in detecting the hand patterns, sir.
Mhm.
The processing time will be less when we use this OpenCV and CNN, sir.
And you have mentioned that 1 second latency. How you have calculated that real time? gesture to speech translation.
Yes, sir. So we
So
tried. So it
how you calculated that?
so we tried it, sir, and it gives less than 1 second latency, sir. Actually, for displaying a for giving a letter, sir.
Okay, fine. What's your name?
Madhuvanti, sir.
Okay, fine. Thank you very much.
Okay, thank you, sir.
Thank you,
Over
sir.
to
Thank
you.
you, ma'am. Moving further, up next we have PM Thirishala. She is presenting OCR augmented document summarization with semi-supervised but in low resource settings. Ma'am, are you there?
Yes, sir.
Yeah,
Am
ma'am.
I audible?
Yeah, ma'am. You can start
Okay.
your presentation.
Let me share my screen.
Yeah, yeah.
Okay. Good afternoon, all. Myself Trishala PM from the Department of Information Technology and the College of Technology. Today, I will be presenting our work titled OCR Augmented Document Summarization with some supervised word in low resource settings. So this work focuses on improving how medical documents, especially scanned and handwritten ones, are summarized when we don't have enough labeled data. So let me begin with the background. Introduction. So, in many hospitals, especially in developing regions, patient records like prescriptions, lab report, and discharge summaries are still stored on paper. When these are scanned, the quality is often poor. There is noise and handwritten text and inconsistent layout. Traditional OCS system mainly focus on extracting text, but they fail when handwriting is unclear, medical abbreviations are complex, or layouts are irregular. So instead of relying only on text, our system combines visual understanding and language understanding. So we use VDT19 to understand document layout, OCR to extract text, and BERT to understand terminology, and semi-supervised learning to handle limited level data. So however, exiting research still has several gaps. Here, after reviewing existing literature, we identify several gaps. Most systems treat medical documents as pure text problems. They ignore layered information like tables, headers, or spatial alignment. Handwritten prescriptions and noisy scans are still poorly handled. Then, additionally, many approaches are language specific or region specific, which limits their use in multilingual healthcare systems like India. Very few works explore end-to-end multimodal that jointly learn from image, text, especially for summarization. So we defined clear objectives. The main objectives of our work is to build hybrid multimodal summarization system. Specifically, we aim to combine VGG19, which is Visual Geometry Group, and BERT for better document understanding. Then uses OCR with visual cues to improve readability. Then apply semi-supervised pseudo labeling. Since label the medical data is case and generate summaries that talk clinically relevant and structured over. We also focus on handling handwritten prescriptions and enabling multilingual support. Now I will explain how the system works. Proposed method. So our proposed method follows a multimodal pipeline. First, the document image is analyzed using VGG19 to capture layer and spatial structure. Then, OCR extract raw text. This extracted text often contains error. So we use medical domain word to understand context and current inconsistency. Because we labeled data is limited, we train the model using small labeled set and a large unlabeled set where pseudo labels are generated automatically. Finally, visual and textual features are fused to generate the final summary. So this pipeline is clearly represented in our system architecture. This slide shows the overall architecture. The process starts with image acquisition, followed by pre-processing, such as denoising and squeak correction. Next, VGG19 perform layout analysis. and OC or extract text from detected regions. These outputs are interpreted and passed to the summarization model. The bird generate a structured medical summary. So each component support the next forming an end-to-end system. Now let me briefly discuss the dataset and the implementation we have used. So we evaluated our system using real medical documents such as scanned prescriptions, diagnostic reports, and discharge summaries. For implementation, we used VGT90 for visual feature extraction and OCR engine for next recognition and BERT trained on medical vocabulary for contextual understanding. Since full annotations were not available, we applied semi-supervised learning. Performance was evaluated using metrics like precision, recall, F1 score, and AUC. Let's move on to the results. Our results shows that hybrid VGT19 plus BERT module outperform text-only approaches. The system handles complex layout tables and handwriting much better. The generated summaries are shorter, more coherent, and medically meaningful, which is essential for clinical use. So from these results, we observed several important findings. So the key findings. The key takeaway is that visual and language fusion significantly improve medical document understanding. Semi-supervised learning proved effective in resource environment. The model generalizes well across different hospital formats and support multilingual document. However, like any system, there are limitations. So, our system still has some limitations, performs slightly drops with extremely poor handwriting, and depends on OCR quality. In future work, we plan to integrate stronger vision models and handwriting specific model. We also aim to extend real-time clinical deployment. Finally, I will conclude my presentation. So to conclude, we proposed a hybrid VGT19 plus word-based summarization system for medical document. The system outperformed traditional OCR-based method and generate accurate context-aware summaries. This approach is especially beneficial for low-resource healthcare system. That's all about it. Thank you. Thanks, sir.
Yes. Let me ask you, you have mentioned here, this is only for medical documents, right? Why you have
Yes, sir.
chosen only medical documents? Am I audible?
Yes, sir. So we use medical document because it has a more data we can use with the limited data and also it can create zeros and ones.
No, generally, medical data you will not get easily, right?
Yes, sir.
So what type of document it should be?
So I couldn't hear you.
What type of documents you are looking for exactly
Sir, for
in
this we are
medical?
using first, sir, disease patterns and causes, treatment prescriptions data, sir. We can scan it.
But this policy is already available now.
Sir, but it's available in limited sources, sir. Here we are
Can you
using
show me the
semi-supervised.
comparison? Can you show me the comparison of this PPT?
So I didn't
Result wala,
present
you
any
can show me
comparison.
result. So
Sorry,
you
sir.
should go for
Can
first of all. See, let me tell you one thing. Whenever you are proposing something, some comparison should be there. Why you have chosen this topic? What earlier, existing researchers has done it, and why you have chosen this topic, right?
okay, sir. But we
That is
didn't
not being
add here, sir.
reflected. Yeah, that is not reflected. And another thing is result. Can you show me result? So, had you
Yes, sir.
worked on this result, or you are just predicting that?
So we just predicting for now. We are
Okay.
working on that, sir. We are not completed it, but we are working on it.
Okay.
Okay, sir.
Fine. Thank you.
Okay, sir. Thank you.
Over to you, sir.
Thank you, sir. Thank you, ma'am. Moving next. So next we have Nala Shreyas. Uh, he's presenting real-time audio security, encrypted packet streaming over secure networks. Sir, are you there?
Yes, sir. Am I audible?
Yeah, sir, you're audible. You can start your presentations.
Just a minute.
Yeah.
So, can you confirm if my screen is visible?
Yes, sir, it's visible. Just put it in the presentation mode. Also, Trishala ma'am, you can stop your screen sharing.
Yes, sir. Good morning. I'm Shreyas, and I will be presenting our work titled Real-Time Audio Security, which is a encrypted packet streaming service over secure networks. So I will be going through the motivation, the problem we are addressing, and the cryptographic techniques mainly used, and the architecture, implementation details, etc. So to start with, the motivation is like the real-time audio communication is widely used in mainly the voice calls, secure communications. So here, however, the audio data is highly sensitive, and it is also vulnerable during the transmission over some or the other networks. So here the most existing systems mainly depend on classical encryption, which works well today, but may also become insecure in the future due to many advances in the quantum computing. So additionally, there is a heavy encryption algorithms. They often introduce latency, making them not suitable for the real-time audio transmission. So this is the region that creates a need for a lightweight, secure, and also a future-ready solution that can secure live audio while maintaining the low latency as well. So to go with the objectives, the main objectives is to secure the live audio using packet level encryption, which we have went for, and to use a lightweight symmetric encryption to have a better performance compared to the previous existing works. And then comes the to protect the encryption keys, which are crucial in the cryptography domain, using the post quantum cryptography. And finally, keeping all these intact, we should ensure reliable packet delivery using the acknowledgement mechanisms which we have gone for. So to say about the problem definition, we address this is the development of a secure real-time system. So this should ensure the confidentiality and integrity of the streamed audio packets, and it should protect the encryption keys against any future quantum era attacks. And then, as said, it should also maintain low latency, which will be suitable for live audio communication. To I will brief the literature survey. So we have studied several existing approaches in this audio security. So many of the works use AES and chaotic encryptions, or for that matter cellular automata techniques to mainly secure the audio data. The recent studies also explore some of the AI and deep learnings for this multimedia security and this the data hiding techniques. So some of the works in our study also highlighted the vulnerability of this traditional cryptography to the quantum attacks, and they also proposed quantum post-quantum algorithms like crystals, NTRU, etc. So, however, most of these approaches focus on mainly the file-level encryption. These are not computationally heavy or not optimized for real-time streaming. So in this, like I have summarized this. In this, we have found some of the research gaps. Like the focus is very limited on real-time audio streaming, and they have got a bit more latency, which caused by heavy encryption techniques. And also there is very minimal integration of post-quantum cryptography with live audio systems. So these are what motivated us to design a lightweight, real-time, quantum-resilient audio streaming system. So, so these are the basic tools which we have used. The front end is only concerned to the developers like us, but when we deploy the system, the front end will not be of no use, because the only system working will be the audio transmission system. So to say about the architecture, on the server side, we see the process happening, or the audio is recording using some other microphone, and then it is compressed and encrypted. And in encryption, the first layer of encryption goes with the XTEA encryption, and then comes the second layer, which also like which fills the if any loopholes found in the XTA encryption. So there is the encrypted packets are transmitted over a socket. Like here we have used TCP network for a demonstration purpose, whereas when this will be deployed in the real-time scenarios, such as the when the officers use the walkie-talkies, these will be deployed in those local systems. So, and then if we see on the client side workflow, the packets are received, and then they are decrypted using XTA. Then the decompression happens, and these packets are reconstructed to keep the entire audio in an order. And then the final audio is played using the existing speakers. To say about the encryption, here the first layer we have used is XTEA, which is extended tiny encryption algorithm. So basically it uses a 64 block size and then it has a 128 bit key, and then in the entire encryption process it uses typically 64 rounds of simple operations, like we have XOR, shifts, and also additions in the flow of the working. So because of its simplicity and it has low computational overhead, so this is suited for the real-time audio packet encryption. And then we have the next layer of the encryption, which is the NTRU, which is nth degree truncated polynomial ring. So here, to secure the symmetric key, we have used this NTRU, which is also a lattice-based post-quantum cryptographic algorithm. So this we have used this because this technique is proven to be resistant to the quantum attacks, which we predict may happen in the future. And unlike the existing RSA or ECC, this system has NTRU. This encrypts the XTA key before the transmission itself to the client. So this happens in the server side itself. So this ensures that even if an attacker intercepts the communication, the encryption key remains secure in a quantum computing scenario. So, like as I have said, again, the server mainly records the audio, compresses and encrypts the packets, and then it sends the packet with the size headers, which will be used in the client side to decompress and reconstruct the audio packets. And then comes the client side, which receives, decrypts, and then decompresses the packets as said, and then combines all in a WAV format, and then into the MP3 or MP4 format as suitable for the deployed system. And it uses a Fernet domain for the encryption, and Z library we have used with the Python coding, and then these are the these are the basic typical UIs which we have developed to make people understand what's happening inside the system, the server and the client. So when we deploy the system, these UIs are of no use, because only the audio encryption, safe transmission and decryption will happen. So like we see the receive and play complete audio, this for the client, and then the start recording is for the server, and then we see the acknowledgement packet, like ACK packets which we have kept for each packet. So whatever the packet is sent, it waits for the acknowledgement, and when the acknowledgement is received, it then starts to send the next packet. So in the testing phase, the implemented system was tested for the packet transmission. As I have said, the ACK response. When we get the ACK response, the system prepares to send the next packet, and then we have checked the encryption or decryption correctness, whether they are working in multiple scenarios, etc. And then we have checked the audio playback quality, because we have got that of the many of the trials we have did, the quality was better. We didn't measure the quality of the audio, but it is a way much better, so that the opposite person can have the message received correctly. And then we have handled the simulated disconnections. So to compare our work with the pre-existing works, so we as we have tried only using our local systems, so we got the packet loss of 0, but we assume this packet loss is 0 is not possible in the real-time scenario. It may go to 1 and 2. So the average packet delay, we got 100 milliseconds by comparing our work. And then we have throughput, which is the packets per second. We have 21.6 throughput, which is higher as compared to previous existing works. Like packet loss, as I have said, 0 is for our systems when we have tried only in our local deployment services. When we try in the other services, the packet loss may increase. And then if we see the computational encryption overhead, the encryption time takes about 3 to 5 milliseconds, comparatively low when compared to the other existing works. And then we have CPU load, which is also proven to be low, like it ranges around 20. And then we have key size bits, which is 128, which is a standard one when we use the quantum encryption techniques, etc. So to compare with other systems, our cipher type is also lightweight. And also we have used the combination of XT array and NTRU. So like the results have already been told. So as when we play an audio, it transmits the 216 packets in about 10 seconds, and then average delay per packet is 100 millisecond. So as I have said, we have got 0 for now, but we may predict some or the other packet loss in the future when deployed. And the playback is clear and synchronized. Like there is no mismatch in the reconstructed WAV files. So like if I can see these, like the in the client side, there will be 2 files which will be decrypted received. All the bin files, WAV files will be received in the stored in the received folder. Then they will be decrypted as mentioned, and then we can feed a complete audio, and we can listen to that. So to coming to conclusion, so in conclusion, we successfully implemented a secure real-time audio streaming system using hybrid XTA and NCR encryption system. So the future work can include multi-client support model, and then we can also have improved authentication mechanisms, and this can also be extended to the video and audio combined streaming platform. So these are some of the references we have referred to. Yes, thank you, sir.
Thank you, sir.
I can say that it was very good presentation, as well as the work you have done is very nice. My concern is, if you work on the UDP protocol, how it would be?
Sir,
if you work the system on UDP protocol, then how it would be?
Oh yes, sir. Sir, we coming to UDP is actually more appropriate for this, but there are many conditions included, because there is no head of line blocking. For example, the late packets are dropped, so they're not delayed. But if the packets are dropped, there will not be any clear communication to the client from the server, because we need full message to be passed with the low latency. as you have mentioned, we can use UDP with a lower latency than TCP, but the packets which may delay, they will be dropped in the UDP protocol. So that's the reason we have gone with the TCP itself.
So what about the socket programming? What about the if any socket fails in between, how intimation will be come to us?
Uh, so because we have this ACK based acknowledgement system, so we can know if the packet is transferred or it is not transferred. So only if the acknowledgement is received, the server prepares to send the next packet.
Okay, well done.
Thank you, sir.
Thank you, sir. Moving further, next we have Samparani Bhadra. She is presenting retrospection of deep learning models towards diagnosis and prognosis of Alzheimer's disease, a comprehensive review and meta-analysis. He has some technical issues. Let's move further. Next we have Chetan ND. He's presenting seamless audio video translating from English to multi languages with enhanced clarity.
Self Chetan India, I'm presenting about seamless audio or video translation from English to multiple languages using NLP. As global connectivity increases the demand for the fast and accurate translation of audio and video, current is raising languages barrier limit according to exist. Tools often lack context, leading and confusion. This project aims to develop a reliable AI-powered translation system with speech recognition and voice synthesis, ensuring clear and accurate communication for students, professionals, and content creators. Problem statement. The current translation tools often introduce error in punctuation, tones, and meaning. Additional existing system struggles with real-time translation and context preservation. There is need for intelligence, adaptive and effective translation system that overcomes those limitations while ensuring high accuracy, natural flow. Main objective, machine translation engine, convert text into different languages with grammar and context accuracy, text-to-speech synthesis, turn on text into natural sound and speech, noise reduction and context analysis, clean the audio and context clear translation, unwanted speech removal, it removes filters and irrelevant noises in the transcriptions. Technologies used speech recognition ASR model of OpenAI Whisper model, translation Google Translator API. For voice synthesis, we are using Google Text to Speech. For video editing, we are using MoviePy and SoundPy and NumPy and FFPGA. For report generation, Report Lab and VisiPrint. And backend, we are using Python and Plus. For frontend, HTML, CSS and JS. Existing system Google Translate popular for text and speech translation, but understanding and content. Deep translation delivered excellent text and translation, but lack of time and speech translation. Manual translation service contextual, accurate but slow, cost and for real time needs. Suitable generation tools struggle with noise and accents and terms. Proposed system audio extraction and transcript. Extract the audio and transcript using OpenAI Whisper model. Translation and speech generation, translate and transcribe text and speech with a GTTS model. Synchronization output generation, align the translated audio with the video timing and create a dubbed version. Web interface and optimization, develop a user-friendly interface and optimize. Methodology. We are using upload stage audio extraction, speech recognition, translation, text to speech, video processing, transcript and report generation, packaging and downloading result. First we upload the video, then it extract the text from the audio and it converts to targeted language and again it convert to text to speech and it merge with the audio and it come as the video as the output. So these are the result. Here we upload the video. Which language we select, which language we Hindi, Kannada, Telugu, Tamil. We can here is it will convert if you targeted language. We can it is the original text and it is a translated text. This research represents a real-time seamless audio, video, and translation system that effectively bridges barriers by integrating open source ASR, MT, and TTS technology. The system achieves strong qualitative outcomes in translation frequency and synchronization while maintaining a natural speech quality, successfully address the limitation of traditional translation method and commercial tool, lacking support for diverse regional languages.
Hello. Am I audible?
Yes, sir.
Yes, sir.
Jason, am I audible?
Yes, sir.
No, this system is already being implemented, no?
Sir, I have used sir,
No, this system is already been implemented. What's the next challenge you have been opted over here?
sir, I'm doing noise reduction and context analysis and unwanted speech removal.
Text to speech synthesis is already there. Noise reduction, context analysis is already there. So are you going to integrate all these four objectives in a one research?
Yes, sir, I have implemented in one research. Are all four objectives.
Okay, and all languages?
No, sir, only four languages: Kannada, Tamil, Telugu, Hindi.
And what is the accuracy of these four languages?
Sir, it is 93%.
Overall or
Yes,
individually?
sir, overall.
Okay, fine. Thank you very much.
Okay.
Thank you, sir. Do we have Sampa B?
Yes, sir. Sir, am I audible, sir?
Yeah, ma'am, you are audible. You can proceed with your presentation.
Okay, sir. Sir, my topic is retrospection of deep learning models towards diagnosis and prognosis of Alzheimer's disease, a comprehensive review and meta-analysis. We are three authors. I am Shamparani Bhadra and my two co-authors are Shanghamitra Addo. She is a co-guide also, and my PhD guide is Dr. Joya Sheel. So I am presenting this paper for towards completion of my PhD thesis. So the abstract I am reading out is Alzheimer disease is an irreversible neurodegenerative disorder which when left untreated may cause death of the patient. Since the early symptoms of AD are more likely mild cognitive impairment, therefore an early detection and diagnosis of the disease may save the patient by providing right treatment. This paper presents a review article on comprehensive study of different methods for automated detection and gradation of various stages of Alzheimer's disease using traditional machine learning and deep learning models. This study also includes the ways of presenting development of Alzheimer's disease from MCI. The aim of this study is to understand application of different techniques for image synthesis, data augmentation, image preprocessing, image segmentation, feature extraction, and selection of classification model for increasing diagnosis accuracy of Alzheimer's disease. A meta-analysis is presented in the later section of the paper. Both the merits and demerits of the existing methods are discussed
Your
and
PPTs are not
futures.
moving up.
Sir?
PPTs are not moving.
Uh,
Now
okay,
it's
sir.
moving.
So now it is, sir. Both the merits and demerits of the existing methods are discussed and future scope is suggested for further improvement. Sir, this is the abstract. Now we will go to the details. I will now discuss the introduction to Alzheimer's disease. What is Alzheimer's disease? It is a type of mental illness which is occurring in the elderly people where a person becomes forgetful, a loss of memory. They have difficulty in concentration, confusion in carrying out daily tasks. They have speech struggles and poor judgments. There are very fast mood changes, and as the time passes by, the patient's health condition deteriorates severely, which ultimately leads to the death. So, there is no cure to this disease, but an early detection can slow down the progression of the disease. So, how we are going to detect Alzheimer's disease from the medical images? The automated detection with the help of computer aided diagnosis CAD and medical images like MRI, CT scan, PET aids the doctor to identify the early stages of the disease, thereby differentiating Alzheimer's disease to that of MCI. So MCI is mild cognitive impairment. From the images also, here I have tried to show different types of states of a dementia. Dementia is a wide range, and from there a small part is Alzheimer disease. Others are Pearson disease also. Um, Many types are there. So from the brain MRI, these three pictures are MRI scan of human brain. The first one is cognitive neutral, that is a person is healthy, a healthy brain. The second one is mild cognitive impairment, where a person have small memory losses, but that is not a critical disease condition, and that if it is left untreated, it might become to an Alzheimer disease case, that is where the brain shrinks and the person severely suffers. So the aim of the CAD is to improve accuracy in classifying different stages of Alzheimer's disease by analyzing patterns in medical images using machine learning and deep learning. Machine learning and deep learning are two sectors, different sectors, where deep learning is better than machine learning, which we will study in the later sections. The other brain scans are from CT scan, also from PET, and mixture of MRI CT scan or CT scan and PET, etc. The aim and objective of our study is to understand application of different techniques for image synthesis, data augmentation, image preprocessing, image segmentation, feature extraction, selection of classification model for achieving increasing diagnosis accuracy of Alzheimer's disease. Each one will be discussed in the next PPT slides. The objective is to present a meta-analysis of the existing works. The contents for the next slides are the general framework, the materials and methods. The subsections are datasets, data augmentation and image generation, image preprocessing, feature extraction, classification model, visualization of feature map. Then we present a meta-analysis of the previous works based on all the above 6 parts which I have told, and also I have grouped by the AD diagnosis without augmentation, AD diagnosis with data augmentation, AD diagnosis with augmented data, automated data augmentation, AD prognosis and forecasting. These are 4 different parts where augmentation is to make some um, unreal means synthetic images, but those synthetic images can be made from the original images by flipping, rotating, or doing some image artificial works. And automated data augmentation is synthetic using some deep learning models like GAN, etc. And then we have a comparison and discussion of all the things we have studied together on all the research papers. And finally, we conclude the paper, and among them, we also discuss the merits and demerits of the existing methods, and the future scope is also suggested for further improvement. The general framework is laid here, where we can see the input is provided to this structure, then pre-processing or processing of the MRI brain images or any kind of brain images is done. So getting the images right from the scanner, and those images might have some noise, or those images might not have some proper alignment, so we have to do pre-processing. Those are called pre-processing. Scaling, we have to properly scale them. We can do some atlas mapping also, and then we go for processing of the images. It is also a separate part which we will discuss soon. and these images might be from other sources also, like PET, scan, anything, x-rays also, but x-ray is very harmful, so we go for MRI images. We have advantages for MRI images, it is not harmful. And also that nothing is required to go inside the head, only the rays go inside the head, captures the soft tissues and the non-bone areas, and we get a very clear images. Then we pass it to this section where a generator and discriminator is provided. This one is for getting some synthetic images, where we get some synthetic images for data augmentation that may be traditional or automated. This is because sometimes we lack images, or the data set is not very strong to predict whether the person will have Alzheimer disease in the future. That is which we call forecasting and prognosis. From a continuous therapy or from a continuous disease treatment, the doctor can suggest or the doctor can predict that the MCI patient, a mild cognitive impairment patient, might have Alzheimer disease in future. So that is why uh, this data synthesis part is required, where the missing gaps can be filled so that the doctor can predict for the future.
Ma'am, sorry to interrupt, but your 9 minutes are over.
So how can I further proceed? If I can show the slides, I can run through the slides. So the next part is that we go for the classifier. The task of the classifier is to is to classify the automated images got from those deep learning models and the conventional images. Both the images are compared or a prediction is made and the model is evaluated, that is the accuracy is gained through testing. First the model is trained and then the testing is done. So as I have very short time left, so I am running through the rest of the slides. The data sets which we can go for some very good public data sets for MRI images only, I am telling, that is ADNI, Alzheimer Disease Neuroimaging Initiative, then AIBL, Australian Imaging Biomarker and Lifestyle. Another is OASIS, Open Access Series of Imaging Studies. Another is MyRED, Minimum Interval Resonance Imaging in Alzheimer's Disease. ABIDE, that is Alzheimer's Biomarker in Daily Practice. And Kaggle is another community where mostly people share their own data sets, their customized data sets, and they share the codes, they share their research work, etc. So the data augmentation and image generation, which I have already discussed earlier, is to generate some synthetic images by rotating, flipping, etc. SMOT is another alternative where an intermediate features are generated by applying some mathematical calculations over the other images. Deep learning tools are also used. Adversarial networks, GANs are all used here. Image pre-processing, as I have told, we have to apply for histogram equalization or intensity normalization, gamma correction, bias field correction, blurring, smoothing, noise reduction, contrast enhancement, etc. Image registration is another part where different images, different source images or other machines might not have the similar structure, so the images may not have the same alignment, so we have to align all the images to a particular degree, so that is called image registration. Skull striping is to remove the bony areas, the skull part, and only to capture the internal tissues. Segmentation is to divide the regions, brain regions like white matter, gray matter, cerebrospinal fluid, hippocampus to different segments, and we can also analyze the accuracy of future prediction through studying the different segments of the brain. some screen means some work is shown here where the image pre-processing tools are available. We can also do it using our own Python codes or any other language, computer language. So MRIB software library FSL is one of the good available pre-processing tool. Free surfer, statistical parametric mapping is another one. So here I can show that the original images first having the skull, the outer white region is the skull. We have removed and got the inner soft tissues. Then we have segmented the area into the gray matter, white matter, different parts. Then we have normalized, applied some mathematical calculations to get the normalized images, smoothened the images. So we have all mathematical calculations. And we have feature extractions. Like feature extraction is applying the handcrafted algorithms or the deep learning or machine learning algorithms, and to get the feature map of the image. Instead of the image, the feature map becomes very useful for further calculation. It is lightweight also. So I am not going into very details. Some handcrafted feature extraction algorithms are gray level co-occurrence matrix, GLCM, Gabor filters, local binary patterns, histogram of oriented gradients, wavelet transformation, etc. And the others classification models are I will discuss, but these classification models are much more advanced than those handcrafted methods. And we can also use these classification models by pre-training. That is, we will freeze the portion which we want to use, and then we will add our own dense layers according to our need. This is useful when our own dataset is very small. Then those pre-trained datasets are used with the benchmark datasets like ImageNet. First we will train the model, and then we will apply on our own dataset. Now the classification models, there are some benchmark deep learning models are VGGNet, RaceNet, InceptionNet. Each have their own inbuilt architecture which is useful. And next is DenseNet, MobileNet, EfficientNet. Some other are AlexNet, QuizNet, ExceptionNet, Vision Transformer, Swing Transformer. We can mix them and build our own models. These are called hybrid deep learning models. And we can visualize those feature maps using heat map. And some good heat maps are class activation map, CAM, gradient class activation, GradCam, guided gradient class activation, and etc. So next we will go to the meta-analysis. I have studied over 91 sources. So the meta-analysis is grouped into a table, and the meta-analysis is grouped by AD diagnosis without augmentation, AD diagnosis with data augmentation, AD diagnosis with automated data augmentation, AD prognosis and forecasting. And then a discussion is given. So here is the meta-analysis. The first one, the first paper is by Dinagar et al. It is a 2023 paper. Here the columns are partitioned by dataset used. They have used ADNI OSIS dataset. Image processing, what kind of image processing they have applied is only intensity normalization, skull striping, registration. They have not applied any data augmentation. For feature extraction, they have used GLCM, that is a handcrafted feature extraction. The classification model used to classify these features are random forest. Three different types of classifier they have used: a 3D DenseNet 121 and 2D ResNet 18. The accuracy they have obtained is for ADNI 0.723, and they have also classified through the sub data sets. Means for SSL, CL and SL, they have got the three different types: 0.8, 0.9 and 0.8, etc. For OSIS dataset, they have got 0.74. Again, for their subclasses, they have got 0.8,
Ma'am,
0.8, 0.8, like that.
hello,
Yes, sir.
ma'am.
Huh.
Your 9 minutes are over, ma'am. Or your 10 minutes are over.
Okay.
So can you wrap up?
Uh, yes, sir. Yes, sir. Then the next all are the data augmentation part. All are the, like traditional. So this paper has been this here. I am only showing the table, but when you can go through the paper, if you go through the paper, you will find all the write-ups also. They are beautifully written up. So the next one is the next all up to first six. Yes, first six they are using GAN, DGAN, modified GAN, SCM plus style GAN, WGAN. They are for deep learning models. They have used deep learning models for image synthesis. Then I have shown how they are grouped by accordingly, means for data set, what is data set, what is image pre-processing, and the last rest are for future prediction. For future prediction also, I have shown what models they have used, all these things. And the comparison is, see, it is observed that the synthetic image generated by deep learning generates better classification accuracy than the traditional augmented images. It is also noted that better classification accuracy is not only dependent on the data augmentation and image synthesis, but on the factors like proper image processing, segmentation, and application of feature extraction prior to models training and testing. And further analysis shows that both handcrafted and deep features perform equally well for binary classification. However, deep features generate better accuracy for multi-classification. And in addition to classification, visualization of feature maps through deep learning models excels the traditional methods. So I am in short of time, so I am concluding. The conclusion is like, the computer aided diagnosis with machine learning and medical images paved a helping hand for the doctors towards detection of the disease. A proper application of image synthesis, augmentation, image preprocessing, segmentation, feature extraction, and selection of accuracy model, classification model are all necessary for the improvement of classification accuracy. And studies showed that a paradigm shift from machine learning to deep learning models provide a better solution in terms of classification accuracy. Moreover, a analysis of time series data for forecasting the next stages of the disease lays down a milestone towards the early diagnosis of the disease. The references are listed here. The paper contains 91 references which the reader may go through. So here I stop my presentation. Thank you. Any
Well,
questions, sir?
is it your PhD topic?
Sir?
Is it your PhD topic?
Yes, sir. It is my PhD topic. It is a part of the second chapter, literature review and analysis.
Right. Have you received the outcome?
Sir?
Have you
I
received
am.
some results of?
Sir, this is only a comprehensive review. I have also done two, three more papers. There, I have combined the deep learning models. I have taken the best parts, best features of every deep learning model, and I have combined and made a hybrid deep learning model. There, I have received accuracy for around 93, 94%. And if I apply some more validation techniques like k-mean, 5 cross k-mean or cross validation, then the result is around 98, 99%. The training accuracy result becomes.
No, but that is as and when you will do it. No.
Hmm.
Had you got any implementation till now? These are all
Implementation.
predictions you are talking about, right?
Yes, sir. This is only limited to the research works done till now, divided
Mhm.
into all these kinds, group by study, a comprehensive review, and the separate papers
Which
are
one is your
there.
base paper?
Huh.
Which one is your base paper in which year?
Sir, I have combined the feature extraction methods also for
No.
another.
What I'm asking, the base paper is belongs to which year?
Sir, the best paper belongs.
Base paper. How you got this idea?
Sir,
Well,
how I
okay, over
got.
to you, Siddesh.
Yes, sir.
Thank you, sir. So this was the last presentation for the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team ICTCS 2025. I also thank our session chair for chairing this session. A small token of appreciation from team ICTCS 2025 and Global Knowledge Research Foundation and partners. Sir, do you have any closing remarks?
Yeah, thank you very much, Siddesh, and Team ICTCS 2025 giving me an opportunity to serve as an session chair. It was very fruitful and grateful experience. I hope in future we are going to be connected. If any help needed in future in terms of professional as well as personal, I'm always ready for any help. Thank you very much. Over to you, Siddesh.
Oh, yes, sir. Sir, can you forward this paper for the best paper award for this year?
Yes, sure. If you, it is
Okay.
possible, share me the Excel sheet. I will remark there.
Okay, sir. Thank you, sir.
Thank you, sir.
I kindly request
Have a
all
great day.
participants to switch on their cameras for a quick snapshot of the session. Thank you, everyone. Have a safe day.